To another lecture of Psychology 101. I am your instructor, Dr. Shadi Bashai, and today we will be discussing psychological approaches to research methodology, which corresponds to Chapter 2 of your textbook. So if you're following along, this is Chapter 2, and the slides have been posted to your courses. If the last few lectures haven't convinced you why we need very good science, I invite you to stop my lecture here and watch the embedded video here, which is a YouTube clip. And once you've done that, I want you to take a minute to reflect on the following question. How do you arrive at anything you hold to be true? That is, how do you know that anything that you know for sure is actually true? There are several ways we come to believe the things that we believe. And I'll give you an example here. The first is we can accept things based on what someone we hold in a position of authority tells us. Okay, and this is accepting, this is a very popular and often utilized method of knowing. I mean, take for example, you believing the words that I'm saying, you believing the facts about psychology that I'm giving you here today. You take it on my authority based on, my prior history, my credentials, my employment with the university. But you can probably understand why believing everything based on authority, although it works for our society for the most part, you can probably imagine why that can lead someone astray sometimes. And that's, of course, if the authority figure, for example, is misinformed and is therefore teaching and or imparting knowledge that is incorrect. Another example is when an authority figure has been compromised in some way. That is, they're deliberately giving people misinformation. Okay, so that is, it's not a perfect way to know what we do know to be true. Another way, of course, is for us to use logic and reason. And I have a syllogism here, which the way syllogisms work is that you have two premises and then a conclusion that flows naturally from the first premises. Okay, so the premise one here is primates are capable of using language. Premise two, Bozo the chimp is a primate, which of course would ultimately lead us to conclude, drum roll, the Bozo the chimp, who is also a primate, is capable of using language. Well, that's all nice and dandy, and it's all coherent within the syllogism. This evident truth is coherent within the syllogism. But part of the problem, of course, is how do we know that premise one is true? How do we know that premise two is true? Okay, so that presents a conundrum if we're actually trying to know anything to be true. And then there's empiricism, which is something that we've talked about in our last lecture. And empiricism is the process of learning something through observing through our senses. And it's one of those things that John Locke really emphasized. But part of the problem, and we will discuss this in much more detail later on, part of the problem is we're relying on our interpretations of our observations. And that, as we've talked about ad nauseum, I guess, at this point, is obviously a flawed way of understanding the world. Or at least it's an incomplete way of understanding the world, because our senses can lead us astray. Our gut intuitions can lead us astray many, many, many times. And I'll tell you why that is, because we are designed for efficient processing. So our brain creates these things that are called heuristics, which are these mental shortcuts or rules of thumb that that our brain is doing almost behind the scenes. And the reason why that is, the reason why your brain is this compendium of these shortcuts, these heuristics, these oversimplifications, is because your brain is designed evolutionarily to reduce the load that it has to engage in, if you will. That is, your brain is designed for very efficient processing that doesn't really waste a lot of energy. You want to make decisions and you want to make them quickly. So what happens is you start creating these rules of thumb, these heuristics. But problem is, if you create these rules of thumb, you start oversimplifying your reality, but just by definition. By definition. And I'll give you an example of a heuristic here. So take a few seconds to read the following. And the question here is, based on this description that you just read, is Sarah more likely to be a school teacher or a holistic healer? And if you're like most people, you'd probably say holistic healer. And I'll tell you what the problem is, of course. There is this thing that your brain does, this mental shortcut. It's called the representativeness heuristic. And what the representativeness heuristic does is it judges the probability of an event occurring based on some kind of a superficial template that you have in your mind. So you think, oh, holistic healers, as I understand, are into New Age music, and they faithfully follow and read their horoscopes. So this is really fitting into my holistic healer template or prototype. Problem is, if you rely solely on this pre-existing template that you have in your head to make a judgment as to whether something is likely to occur, you might be ignoring or committing a very common fallacy we call the base rate fallacy. And what the base rate fallacy does is that it asks the question, how common is a characteristic or is an event to happen just in the general population? So you can apply that principle, that base rate principle, to the example that I just gave. Okay, so we know, just based on base rates, we understand that there are way more school teachers in existence in the population than there are holistic healers. So just based on the very little information that we're given, Sarah is way more likely to be a school teacher just based on base rates, how often school teachers are represented in the general population. There's also the availability heuristic, or the availability shortcut. And the availability shortcut says that you start estimating the likelihood of something occurring based on how quickly it comes to your mind, or based on how easily it comes to mind. And you can probably imagine why that can lead people astray sometimes, because how quickly something comes to mind could be influenced by a number of things, which is how often you're exposed to that thing. Okay, and I'll give you an example here. For example, people get killed by hot tap water, believe it or not, way more often than people get killed by plane crashes, and people die of giving birth still to this day, unfortunately, way more than there are accidental shootings. And of course, you don't hear about people dying of hot tap water or from birth on the news, and therefore you're bombarded by information related to something that, based on the base rate, is very low, or at least it's much lower. But your brain makes a judgment based on how quickly this comes to mind. And again, this is influenced, of course, by how often you're seeing it in the media, how often you're exposed to it. So it makes a judgment based on how easily this thing comes to mind, and of course that can lead people astray. There are other ones, and so a heuristic is a mental shortcut. A cognitive bias, by contrast, is a systematic error in thinking that people engage in more often than not. And by systematic, I mean consistent. People show this bias in thinking consistently across time and across different situations, unless trained to catch it. And even then, I mean, you can imagine I'm probably trained to catch this stuff within myself, but even then I'm just as prey to them as anyone else. But these are systematic errors in thinking, much like heuristics. Heuristics are shortcuts. Biases are more strictly negative, or more strictly can lead to erroneous conclusions or consequences. And two examples of this are on this slide. The first of which is the hindsight bias, which is this idea that you knew it all along. You saw this coming a mile away. And of course, we've all had these moments in our lives where, something happens and you think, oh, well, I should have seen this coming. There were signs all along. But if we are saying this, if we are making this judgment, we are, of course, committing the hindsight bias, because if we knew it all along, we would have known all along, of course. And then the second bias, which is the overconfidence bias, which is it's like a bias about a bias, if you will, which is your overconfidence in your ability to estimate or make a correct prediction about something. Okay, so this is when you think, I'm better at this than most people. I understand that other people fall to these biases, but I'm just way better. I'm way better at estimating whether something will happen, or I'm way better at making judgments. And of course, that's overconfidence. So, I mean, I'm painting a pretty dark picture, I guess, of human reason and human logic. But it is all leading up to this point, which is, how do we avoid it? How do we avoid these biases in our thinking? How do we slow down these heuristics so we're not making mindless mistakes based on these oversimplifications of reality? And really, the only way that I know best to do that is through the scientific method. And this is what we will be talking about for the rest of the next couple of lectures. And the scientific method is based on the idea of hypothesis testing. And hypotheses are predictions based on observations. So based on a number of observations, people start making hypotheses. They generate a prediction about reality. Okay? And then through a set of methods, they systematically start testing whether that hypothesis or prediction has actually come true. Okay, and I'll talk about that in a second. One thing to note, that in science, theories are never proven, and I know this word is used often when I see students writing in a science paper, for example. They say, oh, it's been proven. Well, no, that you can't prove something in science. However, you can disprove or disconfirm hypotheses. Okay, so the science is that strict. You can't prove it, but you can give it support. You can support your findings, and that is reflective of the tentative nature of science. Things change all the time, and our future is the scientific method. The scientific method is a step-by-step approach, a step-by-step systematic approach to addressing a question or solving a particular problem, applied problem. And it uses objectivity, and I'll explain why I use that word objectivity. So there are measures and safeguards in place within science that reduce the influence of the cognitive biases that we talked about, the heuristics that we talked about. Okay, so it's a very systematic way of collecting information, if you will, a very, very rigorous way. And then based on this rigorous step-by-step analysis, we come to a conclusion that solves the original question or validates or invalidates the hypotheses that we have. The first step in the scientific method is to generate questions. And questions could be generated or found in many, many places. Questions could be found about everyday experiences, based on, for example, if your area of interest is psychology, based on why people do the things that they do or why people behave the way that they do. And there are lots of interesting questions that just get generated based on our everyday observations of people or interactions with people on a day-to-day. And then there's your professional experience, right? What you see at your work, what motivates people in their jobs, for example. And then, of course, there are applied questions for which we need answers to, and we probably need answers to yesterday, right? So I'll give you the example of cancer. Many other diseases and disorders that we are dedicating research attention to. And of course, questions can also be generated from previous research and previous findings from previous research, and finally can be generated from theory that are existing about the topic of interest. So you have a question which corresponds to a certain prediction that you generate based on previous research or hypothesis. Okay. And then you have to design your study. You have to implement the steps that I was talking about earlier in the scientific method to best address the question or the hypothesis that you have. Okay? So the design of how you're going to systematically collect information needs to fit with what you're asking. Okay? Part of the problem, of course, is that some questions, especially ones that require an experimental design, and we will talk about that in future lectures, some questions are very difficult to answer with an experimental design because, unfortunately, sometimes it's unethical to do a few things, or it's impossible to do them based on our current understanding or technology or whatever. Okay? There are two approaches to research methodology in psychology, but this is generally in science now. The first approach is a quantitative approach, and the quantitative approach is very much interested in quantifying or putting numbers on phenomena in the natural order, in the natural world. Okay, so this is actually true for psychology as well. I mean, most of the studies we generate in psychology are quantitatively driven, meaning that the researchers, they quantify human emotion, for example. They put it into numbers. They quantify things like human cognition, how often, how frequently you've had these thoughts on a scale of 0 to 5. So that's the quantitative approach, and this is the approach that we will be taking for the majority of this class. And then there's another approach which can oftentimes very much complement the quantitative approach, and that approach is called qualitative approach. And the qualitative approach is less interested in quantifying or putting numbers on things, and more interested in creating a story. Okay, and the way this is done is through collecting information through very detailed interview type questions that you ask people about, and that detailed interview generates lots of information, personal information about people, that you weave together into this narrative or this story to try to understand the world. in our toolbox, there are many tools to try and design experiments or design approach to research methodology. The first of which is called the naturalistic observation, and I'll give you an example of what that looks like. So there is a very famous study in psychology done in the 1980s, and basically the researchers were interested in how people processed emotion. Okay, so they got a group of young men from university who volunteered to take part in the study, and all of the men were required to walk across a bridge, but the men were actually separated into two groups. So all of them were walking across a bridge, but in one condition, the men that were randomized to this condition, they were walking across a very dangerous suspension bridge. Okay? And then there are men that are assigned to another condition, and in that other condition, they're walking across a bridge, but the bridge happens to be much safer. Okay? So if you're understanding what I'm saying, so there's one bridge, there's a group of, let's say, 50 men, 25 of them are going on the bridge that is dangerous. It's a suspension bridge. And then the other men are going on a bridge that's more sturdy. Okay? And then at the other side of the bridge, they meet a research assistant who asks them a few questions, but the research assistant is actually told by the researchers, she's a confederate, as we'd like to call it, so she's a confederate of the research, and she's told by the researchers that after you ask all the psychological questions, actually feign interest in all of these men and give them this number. And what the researchers did afterwards is they actually analyzed how often people in the conditions were more likely to call the woman. And they, believe it or not, the men on the dangerous suspension bridge called the woman more often than the group of men on the more safe on the more safe bridge. And the reason why that is, at least this is how the researchers interpreted it, is that when the men in a dangerous condition walked across the bridge and then were confronted by the female research assistant confederate to the research, they misinterpreted their physiological arousal for attraction to this woman. And the physiological arousal was missing, of course, in the other condition. Okay? So this prompted a big theory in psychology, is that we get information from our body to interpret how attracted we are to things in our environment. So that's just why I'm telling you all this. This is a beautiful example of a type of research design that focuses on doing research in the field, out there, not some cooped up research laboratory, which makes it very difficult for us to generalize the findings onto the real world setting. But of course, field research also comes with a number of problems in and of itself, and I'll talk about that in a second. So observation is all about watching behavior in the real world setting, okay, and or in any setting. So this is the naturalistic methodology. And if you're doing it out in the field, like I was saying earlier, that's very, very good for external validity. And what external validity means is that the findings that I have right now based on this research that I've done, can they be applied to the general population? Can they be applied to other settings besides just your study here? So that's called external validity. But it's a trade-off relationship with another type of validity we call internal validity. And internal validity is all about how much checks and balances were put into your design or your study to eliminate noise, to eliminate what we like to call confounds. And confounds are the things that murky up the water. So if you remember the core principles of science, one of the very first principles that we talked about was, of course, now I can't think of it. It was ruling out alternative hypotheses. Okay? So ruling out alternative hypotheses. So the more checks and balances we can design in our experiments to rule out extraneous findings, extraneous hypotheses, extraneous alternative explanations, the higher the internal validity of our study. So it's a bit of a trade-off relationship between external validity, how much does it generalize in the real world, and internal validity, how much control did I actually have in my experiment to be confident in my result. There are several types of observations. There's what we like to call naturalistic observation, which is basically when you observe behavior out there as it is happening in the real world. And I'll give you an example. Let's say you go out and you ask the question, how often do people hold the door open for someone else? Okay, and that's a naturalistic observation. You're noting down a particular behavior and how frequently it happens in a natural setting. And then there are controlled observations, which are basically when you create a very curated, very neat environment in which you watch people do certain activities. An important example of that, and we will talk about that in the social psychology lectures, is the Stanford Prison Experiment, which was a highly controlled observational type of study. And then there are case designs, which is you observing one case over time. And I'll give you an example of what a case design looks like. So this is a single case design, what we call ABAB design. And ABAB designs, what they show us is, let's say you're employing a new type of intervention, a new type of treatment for depression. In the graph here, in the first part of the graph to your left, A, this is when you're recording or observing the frequency of depressive symptoms. And then in B, you apply the intervention, and then you observe the depressive symptoms, you monitor them. And then in A, so the second A here, you're removing the intervention again. And this is, of course, to rule out, and then you, in the second B, AB, you're introducing the intervention yet a second time. And this is to rule out a fluke finding in the first AB form of baseline intervention application. Oftentimes in psychology, we rely on what we like to call self-report measures, which assess characteristics that would be very difficult to observe, and in fact impossible to observe, including things like personality, things like mental illness, right? Or the presence of psychological symptoms. And the reason why we ask people directly is because, like I was saying earlier, it's very difficult to obviously see these things, and impossible, some would say, although we haven't maybe developed the technology yet. So we ask people directly, how have you been feeling? How often have you been bothered by these thoughts? How often have you been bothered by these symptoms? So that's the first reason, is we can't do it otherwise. And the second reason is we're also confident that people have a good idea of what's been going on. So that people are actually good historians and know that how generally they've been feeling over the last week, etc. So that's self-report measures. And then surveys basically ask about particular opinions or attitudes or abilities. So it's a little bit different than self-report measures, which typically tend to assess or examine things that are happening inside, internally, intra-psychic, as we'd like to call it. So how useful are self-report measures? Well, their usefulness is a reflection of how much they meet two specific criteria. And the first criteria is random selection. And the second criteria is validity and reliability of our measures examined. And we will talk about validity and reliability in the next lecture. But for now, let's talk about this idea of random selection. Okay? So random selection is based on the notion that every single person in your population that you're interested in, let's say you're interested in everyone who's depressed. Random selection says that everybody in the population of people with depression has an equal likelihood of being selected in your study. So that's what random selection means, is that everybody in that population of interest has an equal equal chance to be represented in your study. If the majority of studies unfortunately fail in that criteria, but lots of studies do try to get as a representative as a sample as possible, because the problem is if you have a non-randomly selected sample, that can screw your results, right? So that you could be the people that signed up for your study could be signing up for a particular reason that muddies up the water, again, as we were discussing earlier. Okay, so it muddies up your finding in some way. The fact that they're, the people that self-selected in your study, for example, may be very interested in the topic. And again, that's a unique thing about that population that's coming to see you, and not really the population of people with depression generally. Okay, and like I said, we will talk about reliability and validity in much more detail in the next lecture, but let me give you a hint or a taste. Reliability means the skill or the assessment tool or the assessment measure that you have is measuring something consistently across time and across situations or across different measurements. Okay, meaning it's consistency basically means that if your measure is actually is to be useful, it must show some kind of a reliability across different situations. Okay, and if it doesn't show that, it means there's a lot of error, there's a lot of noise in that particular measurement or assessment tool. Validity is a much more complex but a much more important question, believe it or not, than reliability. And validity is the extent to which a measure assesses what it claims or purports to measure. So if a skill is reliable, if it measures something consistently across time and across situations, and it's valid if it measures what it says it's going to measure. So let's say I develop a new measure of depression. My scale is valid if it actually measures depression as opposed to anxiety or fatigue or whatever it is. So if it's a close representation, if it's a close measure of depression, the concept, then it is said to be a valid measure. Okay, so that's it for this lecture. Until next time.